misi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okey. Assalamualaikum dan salam sejahtera. Pesan. Boleh besarkan saya tak, Cikgu? Cikgu Peh, besarkan saya.
Okey.
Okey ya. Dah. Okey. Saya Cikgu Rosemawati binti Zaini, bertugas di SMK Bandar Bintulu, Sarawak, dari Akademi Youtuber bersiaran dari channel Cikgu Peh. Okey, sebelum kita mulakan kelas kita pada petang ini, lebih molek kiranya kita mulakan majlis ilmu kita dengan bacaan umum kitab Al-Fatihah. Dan bagi yang beragama selain Muslim, kita bolehlah membaca doa mengikut agama masing-masing. Bismillahirrahmanirrahim. Amin amin ya rabbal alamin. Alhamdulillah, bersiaran kita sekali lagi dalam tuition online Akademi Youtuber yang juga merupakan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Okey, sebelum kita mulakan kelas kita, ingin saya ingatkan semua pelajar dan penonton-penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian dengan tontonan umum. Sila fokus pada isi pembelajaran yang akan disampaikan oleh Cikgu Peh. InsyaAllah semoga kelas kita ini akan dapat dimanfaatkan sepenuhnya oleh para pelajar. Ambil peluang ini, ikuti setiap kelas online percuma panitia fizik menengah atas yang akan bersiaran pada setiap hari Jumaat pada 9.30 malam dan pada hari Ahad pada 3.30 petang. Baiklah, saya perkenalkan guru-guru yang ada bersama kita pada hari ini. Cikgu Peh KH yang akan bertindak sebagai presenter kita pada petang ini, dan saya akan bertindak sebagai moderator dan seterusnya control host bagi rancangan pembelajaran kita hari ini. Okey. Juga diingatkan link sijil penyertaan akan diberikan di penghujung kelas. Sila ambil perhatian, link tersebut akan tamat dalam tempoh setengah jam selepas live. Hanya email e-didik Jawi MOE sahaja yang diterima. Alright, tanpa melengahkan masa, mari kita ikuti kelas fizik pada hari ini yang akan disampaikan oleh Cikgu Peh KH. Dengan segala hormatnya, dipersilakan Cikgu Peh.
Okay, so terima kasih kepada Cikgu Yani. Okay, so saya Mr.Peh. Hari ini sebenarnya hari Ayah kan. So di sini saya
Happy Father's Day.
Cikgu Peh. So saya nak ambil kesempatan di sini untuk mengucapkan Happy Father's Day, especially kepada ayah saya lah. Semoga ayah saya sihat, bahagia, sentiasa sejahtera lah. So di sini saya juga nak bagi mesej kepada anak saya. So sebagai seorang ayah, so semuanya kita tak payah apa-apa hadiah yang mahal. So yang penting mereka sihat, bahagia, memberikan keputusan yang sangat baik kepada saya lah. Okay, so di sini saya juga di sini saya nak ucapkan Happy Father's Day lah kepada semua ayah supaya mereka jugalah sihat dan bahagia. Okay.
Betul.
So ada sambut Father's Day, Cikgu Yani?
Macam biasa, bagi ucapan saja.
Yalah, yang penting hati ada kan.
Betul.
Okay, so I wish all have a happy Father's Day lah.
Ya.
Okay, so di sini saya nak buat promosi lah. Okay, ini adalah dua kelas fizik yang diadakan oleh AYU lah. So di sini kita ada kelas tingkatan 5 di mana diadakan pada setiap hari Jumaat 9:30 malam. So minggu ini juga disampaikan oleh Cikgu Rosemawati. Tajuk dia adalah 2.4 prinsip pasca. Okay, so untuk yang tingkatan 4 pula, so sampai turn saya minggu ini, so setiap Ahad 3:30 petang. So ini merupakan panitia Fizik SPM Akademi Youtuber Malaysia. So pada hari ini ada bersama saya Cikgu Yani. Terima kasih bersama saya untuk sampaikan duty lah. Okay, so saya Mr.Peh kini mengajar di College tingkatan 6 Tun Fatimah Melaka. So the title for today's, we still at chapter 2, force and motion 1. And the subtopic we are going to discuss today will be force. So for today's subtopic 2.6, we have actually 2 learning standards. So here will be the first learning standard 1, which is define force as the rate change or momentum. So last week, we together with Cikgu Hasnitah, so we know already what is the meanings of momentum. So the momentum is with formula m mass times velocity. So for change of momentum, we know as initial final momentum minus initial momentum now with this formula, where the m will be mass, v will be the final velocity, and u here will be initial velocity. Okay, so today we are going to the further study, so which is related to change of momentum also lah. So the definition of the force is actually related to Newton's second law of motion. So now let us see what is Newton's second law of motion. Okay, so you can look at the statement here. The Newton's second law of motion states that the rate of change of momentum is directly proportional to the force and added in the direction of the applied force. So that means that we need to understand the definition of force. Then we need to understand what is the Newton's second law of motion. So where the statement very clear state that the force is actually directly proportional to rate of change of motion. Okay, so here you can look at the situation. So here we have a car with a mass m. With a mass m and applying a force F. So here can be thrust force, okay, and causes the car moving from initial velocity to final velocity. So thus, the force which is applied is actually directly proportional to the rate change of momentum. So the change of momentum, you learned already at section 2.5. And just now I also recall back with the formula mv minus mu, where there is a final momentum minus initial momentum. Then the rate will be the time taken for the change of momentum. So that the Newton's second law of motion is actually same as the definition of the force, which is directly proportional to rate change of momentum. Okay, so we simplify with the symbol. Okay, just now I mentioned to you already, the F represents as the force applied, M is a mass, V is a final velocity, and U is the initial velocity, and T will be the duration time. So from this formula, we can actually further simplify as this, where we factorize out V, U, and T. So we actually can represent as acceleration. So this part will be able to represent as A. So we get F is directly proportional to ma, which is the formula we use in Newton's second law of motion. Okay, then we get the value K, which is 1 here. So you can look at this statement. In SI unit, 1 Newton is the force that produces an acceleration 1 meter per second square when the force applied on the mass of 1 kg. So you can see here, F equal to kma, with the F equal to 1, m equal to 1, a equal to 1. So we get the value K is actually also 1. Then we can finalize this formula, F equal to ma. So this is the theory regarding the Newton's second law of motion, which is related to the definition of the force. So here we can conclude that the definition of the force will be force as the rate change of momentum. So this is a statement which is related to Newton's second law of motion. Okay, with the formula, force equal to change of momentum over time. This formula, which will be further discussed at our Learning Center 2, the problem solving regarding the formula F equal to ma. So we'll use 2 formula for this subtopic 2.6. Okay, so from here, with these 3 terms, F equal to ma, so here we want to see the relationship between the force, mass, and acceleration. Okay, so here we can rearrange the formula. So we get A equal to F over M, right? We just move the M to another side, become divide. So we can get A will be relate to F and M. So from here, from this equation, after we arrange, we can see that the A is directly proportional to F, where the M is constant. This is the first relationship between A and F with M equal to constant. So here you can see clearly from this equation. Okay, so A is directly proportional to F. So the acceleration is directly proportional to the applied force. So that means when we apply greater force, the object will be accelerate with higher value. That means we'll be moving more faster. And M will be constant when we study the relationship between A and F. So the graph we expected will be this lah, where we learned at section 1.2 already. So A and F is directly proportional. So it will be a straight line passing through the origin. Okay, so this is the first relationship between A and F with fixed value of mass. Then from this equation, we can get another relationship between A and mass, and the F will be constant. So you can look at here, A and M, the relationship will be inversely proportional, where the value of force added will be constant. So the acceleration of an object is inversely proportional to its mass. So that means when there is a constant force applied to an object, so the force is constant, the smaller mass of object will be moving faster. So the heavy object will be moving slower lah. Okay, we can imagine like this when we see the relationship between the acceleration together with the mass. So the graph will be expected. We get this. A and M is inversely proportional. Or you can represent with this graph. A is directly proportional to 1 over M. Okay, so these two graphs will be represented that the acceleration of an object is inversely proportional to its mass. Okay, so from the textbook, you can see we have the activity to study this relationship. Okay, so there are two experiments are going to do at school, which is first relationship between A and F with the M constant. Then the second activity will be A will be inversely proportional to M with the F is constant. Okay, so now let us discuss the first experiment, which is to study the investigation, to study or to investigate the relationship between acceleration and the force applied. So that means here the A we expected will be increases with the increases of the value of F, and the M will be always constant. Okay, so here you can imagine the relationship between A and F here with this situation. So from this figure, you can see there is two men, A and B. So both will be pushing the object, okay, on the trolley. So the mass is actually the same. For example, both will be 5 kg. Okay, so here you see two men pushing the same mass, but man A pushes a greater force. So you can see the action, okay, the action on the picture. So the man A will be applying greater force. So you can see the trolley A moving faster with greater acceleration. Okay, so you can see, so he moved faster. So this is what is actually related to the F equal to ma. Just now we learned already. So the F and A will be directly proportional. And now we want to prove whether this is true or not. Okay, so the question, the experiment asks you to give the inference. Okay, so we actually already teach many times. So the inference will be like this. You need to write a statement like this. Depends on will be at the middle. The front will be RV. The back of the depends on will be NV. Okay, so from figure you can see the force is manipulated where the A apply greater force compared to B. And we see or we observe the trolley A moving faster compared to trolley B. So the inference will be right as the acceleration depends on the applied force. So this is a way how we write the statement for inference. Then for B hypothesis, you can using the normal way where you can see from the discussion just now, the A will be increases as the F increases. So the statement will be the larger the force, the greater the acceleration. Okay, and then the manipulated variable. So we already explained. So the force will be manipulated variable. Okay, you can just give force, or you want to give a complete sentence as force applied on an object. Then the next will be the responding. So where the situation we observe on the figure will be the acceleration. Then the constant variable we discussed already, when we study the relationship between A and F, the mass of an object must be constant. So the here answer will be mass. So yes, I think this is quite straightforward. Okay, so for study this relationship, you need to using the ticker tag. We want to get the result of the ticker tag, and then we calculate. And the way the method we calculate the acceleration, you actually already learned at section 2.1. Okay. Okay, so let us look at the procedure, which is quite similar to the procedure stated in the textbook. Okay, so set up the apparatus as shown in diagram above, and the theory we apply will be with the mass of 1 kg. So this is the first statement. Normally, student is advised to write when they're doing the paper 3. Okay, where the procedure is not provided, okay, for the amali tidak berbantu. Okay, so this is you have to draw the figure and then give this statement. You will get first mark. Then second, you have to state the manipulator variable for this experiment. So just how we explained already, the MV here will be the force. So the force will be represented by using one elastic string here. Okay, so look at the sentence here. Switch on the ticker timer and pull the trolley down the runway with one elastic string. So we, the one elastic string will be represented as one unit of force. Okay, so when you pull, so you can actually measure the length you pull for the string. For example, maybe 10 cm. So this should be constant for the second MV later on. Okay, so after that, so you will get the result. Okay, you get as the tick on the ticker tag. So from here, you have to calculate the acceleration. Okay, so you have to calculate the acceleration. How we calculate the acceleration? Through the ticker tag you actually learned at section 2.1 already. Later on, we can recall with an example. Okay, and then the next will be you have to repeat another 4 MV and RV. So total we need 5 data, 5 MV and RV. So the sentence will be like this. Repeat the step 2 and 3 by using 2 elastic string. So just now you can look at the figure. Here we're using 1 string to pull. So here you need to add on another string. So it will be 2 strings. Okay, then the third will be 3 string, 4 string. But make sure the length you pull must be equal. For example, just now I give you the length can be about 10 cm. Okay, so that the unit of force is constant here. Okay, so here the 2 elastic string will be represent 2 unit of force. Then 3 elastic string will be 3 unit of force and others. Total we will do until 5 elastic string. Okay, with same length. You can see here, with each of the strings stretched to the same length as the one at the first elastic string at step 2 here. Just now I mentioned to you, which is I stated about 10 cm just now. Then again, we will get the result where there is a dot, okay, on the ticker tag, and you need to do calculation with the method you learned in 2.1 already. Okay, So after we get the value of A for respective numbers of elastic string, you need to plot the graph F and A. So the graph will be like this. A will be RV. We get the value through the calculation based on the ticket tag. And then F will be 1 until 5, which is represented as 1 unit of force for 1 elastic string, 2 unit of force to 2 elastic string and others. Okay, so here I will show you one result. Okay, so for example here I show you the result for first ticket tag. Okay, so when you get with 1 elastic string and 1 trolley. Okay, so it will be cut. Okay, you have to cut lah. So become like this. Okay, so we measure the first strip to calculate the U. So be like this. So here will be 2.5 cm. And then here we have 10 tick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one tick will be 0.02 because the normal ticket tag will be using 50 Hertz, which is 1 over 50 equal to 0.02. So that means one tick here will be spent 0.02 seconds. Okay, so you get 10 tick, so you get this value, 12.5 cm per second. And then further, the next will be we calculate the V, final velocity, with the last strip here. And here you can see the length will be 5. Okay, it will be 5. And the time taken for 10 tick will be the same. After the division here, you get the value is about 25. Okay, and then how we get A will be with this formula. V minus U minus divide T. So V we get 25. U we get 12.5. Time taken for the example here, you can see total we have 6 strips. 1, 2, 3, 4, 5, 6. So for calculate the time taken, so we will minus 1 strip. So we get 5 times 0.2. So the time taken for 1 strip here is 0.2. 1 tick 0.02. 10 tick will be 0.2. Then we get the value for A with 1 elastic string and 1 trolley will be 12.5. Okay, so this is one of the example. Okay, so here we need to have 5 data, just like I mentioned to you already. So here will be the first 1 elastic string, we get 12.5. So here will be the reference answer for you lah. Okay, so example, we're using 2 elastic strings. Okay, so we'll get 25. So that means you have another strip lah. You get, and then you repeat the same method. Okay, as what I explained just now, you cut to 6 strips or others lah. Okay, and then you calculate the U, V, and A will be this. Okay, and then we need to plot the graph A against F. So it'll be like this. Okay, so just now I mentioned to you, the 1 string represents 1 unit of force. So the value will be 12.5. Then the highest value here will be 62.5. So your scale for Y axis here, which is A, must be cover the maximum number here. So here will be 70. Yeah? Okay, so for the first value will be 1 with 12.5. So it'll be about here. Then the second will be 2 with 25. So it'll be about here. And then third with 37.5 will be about here. And others lah. Then this will be a straight line. So the graph showing that the A is directly proportional to F with the constant of the mass here. So will be the mass of the trolley, which is stated as 1 kg just now. Okay, so this is the first experiment where we study the relationship between A to F, and you should be get direct proportional with the constant M here. Okay, okay, and then the next will be another experiment. The second experiment where to investigate or to study the relationship between acceleration with the mass of the object. So the mass of the object here will be the mass of the trolley lah. And then to study the relationship between A and M, the F must be the same. So that means here, the experiment, the numbers of strings must be equal lah. Okay, but the numbers of trolley will be different. Okay, so let us look at the situation here. Again, you can see two men. So both of the men applying the same force. You see the statement. Two men exerted the same force, but here you can see the mass of the object pulled by the man, respective man will be different. So the air will be heavier. Just now I use 5 kg represent one box. So here we have 4 boxes, about 20 kg lah. And then the mass carry pulled by the man B will be 5 kg. So you can see the man B will be moving faster. Okay, because the mass is lower. Okay, so if you can, according to this theory lah, so the lower the mass, the higher the acceleration. So the trolley will be pulled faster for man B compared to A here lah. Okay, you can see B move faster than A. Okay. Okay, so the inference again using the same method depends on at the middle. So the front will be RB, acceleration. And then after the depends on will be mass, which is the responding variable for experiment 2 here. Okay, so the answer will be the acceleration depends on mass of the object. Okay, then B hypothesis, the greater the mass, the smaller the acceleration. So you can just look at the equation here. Oh. Then the next will be manipulated variable, which is mass, mass of the object. And then the responding variable will be the acceleration. The fixed variable here will be force apply. Okay, force apply on the object. So this is a quite straightforward discussion answer here lah. Oh. Okay, and then here again you can see there is a quite similar apparatus arrangement with the experiment 1. Okay, using ticker tape again, ticker timer, elastic string, and others. Okay, so you can see set out the experiment. Set out the apparatus as shown in the diagram above. So again, you can see in this figure using one trolley, so the mass will be equal to 1 kg lah. Okay, and then the string here will be different already. We're using 2 string for this study. Okay, so the 2 elastic strings will be always used with different numbers of trolley. So that means with the equal numbers of string, so that means the force will be equal lah for this experiment. Okay, so for the first MV, here will be again switch on the ticker timer, pull the trolley down the runway with 2 elastic strings. stretch together. So again, we must stretch with the same length. For example, 10 cm, just now I mentioned to you. Okay. Okay, and then the responding variable will be, again, we need to calculate the acceleration. So you will get the result of the tick, okay, of the dots on the ticker tag, and then you calculate the A with the same method I showed you just now. Okay, so this is the first responding. And then the third, you can see we repeat step 2 and 3, but now 2 trolley are stacked together. You can see the figure here. 2 trolley stacked, so that means the mass will be 2 kg for 2 trolley stacked together. And again, you can see the numbers of the strings we use is still 2 elastic strings. Okay, so now the difference here will be numbers of trolley. So okay, so where the mass is manipulated variable here, and then the force will be constant since we're using the same numbers of string here. Okay, so the experiment will be then repeated with 3, 4, and 5 trolley, and the numbers of strings will be still the same, where is 2. Okay, with the 2 of the string stretch with the same length, just like I mentioned to you already. Okay, so again, we will get the result in table, and we plot the graph A against reciprocal of the mass. So we expected get A is directly proportional to 1 over m, which is showing that the A and m is actually inversely proportional. Okay, so again, so this is one of the example. Okay, so the result of the ticker tag we get already, then we cut to become this figure. Okay, so from this figure is the result for 2 elastic strings and 1 trolley. So the first result, so we get the U with first strip. So the length will be 1.0 cm. Then the time taken will be, again, with same method, 1 tick will be 0.02. With 10 ticks here will be 0.2. So we get the result, the value will be 5 cm per second. And then V, we are using the last strip's length, which is 6 here. Divide with same time taken, we get the D. Then the A will be using the same formula, V minus U over T. So V will be 30, where we get here. 5 will be here. Divide with the same time taken. So here with 6 strips minus 1. 1 strip time taken will be 0.2. So we divide, we get the A will be 25. Then we have to put into the table. So the table, the first, we're using 1 trolley. So that means 1 kg. 1 over 1 will be 1.00. So here we explained at section 1.2 already. So the table must have the parameter, okay, and represent mass, and then we need to have a unit, okay, and then we need to have the consistent decimal places lah. So here will be 2. I put 2, so others will be need to have the same decimal place. Then A we get 25. Okay, again, this is a reference answer. When we stack with 2 trolley together, so we're using 2 trolley will be equal to 2 kg. So 1 over 2 we get 0.5. So again, this result you need to calculate based on what I explained just now here. Okay, so you'll get the second strip. Then you cut again. You have to calculate your U, V, and A again. Only you get 13. Okay, 13.0 here, and then 3 kg because we're using 3 trolley stacked together. 1/3 will be 0.33, and also others. We get the result with same way. And the graph we're going to plot will be A against 1/m. So we will see these two row result only. Okay, so you can see here, smallest value 0.2, highest value will be 1 for the y-axis, x-axis here, which is 1/m here. So must be have the parameter and the unit also. And then again, the next y-axis will be A. The unit we're using here is cm per second. Okay, so the first will be using this value 0.2 with 5, so be here. Okay, so you have to mark the first value. The second will be 0.25, about here to 7. Will be about here, and others also. Again, we expected will be a straight line passing through the origin. Okay, when we plot the graph A against 1/m here, so that we get the relationship A to 1/m will be directly proportional, which showing that the A and M is actually inversely proportional, where the F value is constant here. Okay, so this is the 2 experiment you are going to do, which is same as the textbook at your school teacher later on. Okay, so Cikgu Yani, kita boleh rehat seketika.
Okey, kita berehat sementara. Kita dihiburkan dengan iklan. Okey.
What's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through. Times don't fly too high. Be sure to keep the ground in sight. Fly forever if you keep it tight. Love the world but keep the sky on your mind.
Okey, kita serahkan semula kepada Cikgu Peh ya. Okey, silakan Cikgu Peh.
Okay, terima kasih kepada Cikgu Yani. Okay, so we actually already finished the learning standard 1. So we are going to learn learning standard 2 here. So the learning standard 2, you have to solve the problem involving F equal to ma. So this is the formula related to Newton's second law of motion. Okay, so before we go to the question, okay, so you need to understand the magnitude of the F here. Just now, F equal to ma. The F is actually the magnitude of the resultant force of an object, and this resultant force value is actually depends on different state of motion. For example, the object is in stationary, in constant velocity or acceleration. So that means here we are going to discuss the magnitude of the resultant force will be affected by these three different state of motion here. Okay. Okay, so with the Newton's second law of motion, we very clear that through the learning center 1, the equation here related is actually F equal to ma. And you can expand to become, just how we mentioned, A is actually V minus U over T, so that you are able to get another formula with this. So both of this formula is actually come from the Newton's second law of motion. Okay. Okay, so here the F is actually represent the resultant force on the object. And the value will be different, so that you need to able to differentiate and get the actual value or magnitude of resultant force. Okay, so here is actually depends on the condition where we know as the balance force and unbalanced force here. So the balance force definition will be there is no any net force added on the object. We know as net force is 0. The net force have the same meaning as the resultant force. So that means you can give resultant force is 0 for the definition for balance force here. And then for unbalanced force will be net force is not 0. So that means there is a value for F here. Okay, so from this table, we can classify the state to these two different type of force here. So just now I mentioned, balance force where the net force is 0. So will be at the stationary state when the object is not moving, or the object is moving with the uniform velocity. So the uniform velocity is actually we know as also 0 acceleration. So from the equation F equal to ma, when the A is 0, so definitely your F or the resultant force here will be 0. Right? Okay, so that means you actually can be relate this equation F equal to ma to the resultant force already. When you know A is 0, okay, where occur on the object in rest condition or uniform velocity, so the net force will be 0, which is under balance force condition. Okay, so on the other hand, you can see when object is moving with uniform acceleration or deceleration also, so they will be have the net force because the F equal to ma, the A is not 0 anymore. So your resultant force will be not 0. Okay, so this is a simple way you can actually using logical thinking to get whether your resultant force is 0 or non-0. Okay, so here will be when the object not moving and in the uniform velocity, the condition we also know as 0 acceleration. So from this equation, F equal to ma, when the A is 0, F will be 0. Okay, so I hope that you very clear how you identify the value of F here. Okay, okay, so here I give you an example. So there is a car which is in stationary state. Okay, so the W is the weight of the car which is adding downward due to gravity. And then there is a same magnitude of the force which is added with the opposite direction. So this will be applying the Newton's third law of the motion. Okay, so there is the action and the reaction on an object. Okay, where the magnitude will be the same but is in opposite direction. Okay, so here R and W will be the same. And when the object is not moving, so the left and right force side is actually not have any value. So from here, V0, A0. So the resultant force, here you can see there is only vertical component have the force added to car, which is R and W. And W and R will be the same. So you can see the resultant force will be 0 lah. Okay, so second state of motion here will be regarding the uniform velocity. So here you can see when an object is moving with certain value of velocity. Okay, so there is a thrust and the friction added to the horizontal component besides the vertical component here. Okay, so here the velocity is constant. So constant velocity will be 0 acceleration. Just now I mentioned to you already. Okay, so the air is 0. That means the net force is also 0 actually. Okay, so for the resultant force for the vertical component, here will be 0 lah. Since the car is at the same height, okay, it's always on the floor lah. Also, that means there will be R equal to W here. And then next will be the horizontal, which is relate T and FR here. So T and FR will be equal since this is in uniform velocity. So the resultant force will be 0. Okay, and then the next here will be regarding the case under unbalanced force, which is there is a acceleration on the car here lah. Okay, so the car is moving at acceleration. Okay, so velocity is increasing, so the acceleration is no more 0 here. So that means there is a net force added on the car. Okay, so for the vertical, it's always the same because the car is always on the floor, right? Okay, so the weight and the R is the same. Then for the horizontal, the thrust here will be greater than frictional force, so that the car can moving at certain acceleration value here. So T is greater than FR, so the F is no more 0. So the force is unbalanced here. Okay, so I say you're not so clear about the theory. So now let us move to question. You will be more clear. Okay, so the first question here is the question regarding regarding the SPM 2005 paper 1, question number 9. Okay, so the diagram shows forces F1 and F2 exerted on the wooden block placed on the table surface. So the friction between the block and the table is 2. Okay, so the friction is always opposite the motion. For example, here you can see 5 and 7 for the option A. Okay, so question asks, which pair of the forces F1 and F2 causes wooden block to move acceleration? So that means we want to see whether there is a resultant force between F1 and F2. Okay, so for here you can see F2 is greater, so the object is moving at the right side. Right, here will be right. So the friction will be moving opposite. 2 Newton will be here. So the F1 will be 5. F2 is 2. Frictional force is 2. F2 is 7. So you can see 7 minus and 2 will be the same. So that means here 7 minus 5 and minus 2 will be 0. So that means there is no resultant force. No resultant force, that means A will be 0. Okay, so there will be no any acceleration occur for pair of A here. Then again, we look at the second. B, here F1 will be 3. So here will be greater. So when the motion moving, here will be left. So the friction will be at the right. So the F2 here will be 1. So you can see 3 minus 2 minus 1 will be 0 also, right? So F equals 0. The resultant force equals 0. So that means there is no acceleration. So because the question asks which pace have any acceleration. So we check again for C. Okay, so C, the F1, crater. So motion will be here, 6. So the friction will be opposite the motion, which is 2 Newton. Okay, at the right. And then the F2 given as 4. So you can see 6 minus 2 minus 4, 0 also. So there is no resultant force, no acceleration. So for the last here, we check D should be have a resultant force because we want to get the answer where there is a resultant force. That means there is an acceleration. Okay, so here F1 is crater. So F1 will be 4. So the motion will be at the left. So the friction will be at the right. So given F2 as 1. So from here you can see 4 minus 2 minus 1. So we get 1 Newton. So the resultant force is 1 Newton. So that means there is a value of A. Okay, so the hot tips here is to produce motion, the forward force greater than backward friction. So this one will be for D lah. So we get the answer here will be D. Okay. Then the next will be question number 2. Is an example question from 2007. Question number 7. Okay, so here diagram show a car with a mass. Okay, you can label as a symbol mass like M, 1000. So the acceleration given is A, 2. So the frictional force is 900. So what is the force assessed by the car, by the engine of car? So this is a thrust T lah, you need to get the value. Okay, so here the thrust will be in front lah. So the friction will be behind. Okay, so here F minus 900. So the F here is actually T lah, thrust. You can using thrust lah. So overall is a F lah. So T minus 900 equal to MA. So we just substitute all the value. F minus, so it is a T lah, we want to get a T. Minus 900, which is the friction, equal to MA. Given by the question, we substitute, we get 2,900. So the answer will be D. Okay. Then the third question here is also one of the objectives you can see as SPM 2010, question number 8 here. Okay, so here the diagram show a toy car. They show a toy car of mass 4 kg. M. The car is pushed forward with value of 10. So there is a friction because the tire and the floor is contact with. So there will be a friction with a value of 2, which is opposite the motion. So what is the acceleration? Again, we're using the only one formula for subtopic 2.6, which is F equal to MA. So the F represent as the resultant force, which is 10 minus 2 lah. M will be 4, and then we can get the value of A. So the resultant force, 10 minus 2, we get 8. So A equal to MA. So we rearrange, we get the A will be 2. D lah. Okay, so here we have another last 2 questions. Okay, so the question number 4 will be the paper 2, question number 2. Okay, so you can look at the question here. Diagram shows forces adding on the moving car. The mass of the car is 1000 kg. So the M given 1000. So what is the meaning of balance force? So the definition we already discussed just now. So the balance force, that means there will be 0 resultant force or 0 of net force. So the answer, net force is 0 will be the answer. Okay, 1 mark. Okay, so that means the thrust and the friction will be equal lah. Since this is a balance force, if I say the question give the statement, the car is moving with balance force lah. So the balance force, we have two conditions. One will be rest condition, another one will be uniform velocity. Okay, so here, when the engine thrust is 5,000, the car move at constant speed. So stack the net force adding on the car. So the net force will be 0 lah, because here the statement given, the car is moving with constant speed. So which is under balance force condition. So the answer will be 0. Because the acceleration will be 0 lah. Or F equal to ma. When a is 0, resultant force will be 0 lah. Okay. Okay, then number 2, what is the resistive force adding on the car? So that means the frictional force lah, or this statement. So since this is in balance condition, so the Fe will be equal to Fr. So the Fe given by the question will be 5,000, where is here lah, right? So the resistive force or frictional force here will be 5,000. So we will get 1 mark. Okay, so C, when the engine thrust increases to 9,000, so the car accelerates. So that means here is no more balance force condition, will be unbalanced force condition already. So what is the value of A? So the car just now we're moving like this lah, where the frictional force 5,000 Newton we get for B2. And now the question given us, there is a changes for the thrust, which is 9,000 here. Okay, and the car mass given as 1,000. So we just apply the one and only formula, F equal to ma. Okay, so the F resultant force will be Fe, the thrust minus the friction equal to ma. Then we substitute all the value we already know. We rearrange again, we get the A is 4 meters per second. So here will be 2 marks. First mark will be for correct substitution. Second mark will be for answer with correct unit here. Okay. Okay, so here we go to our last question. It's an example question from 2016, paper 2, question number 5. So it's regarding the conception, where you will see the question given you 2 figure, 2 diagram, and ask you to do the comparison. Okay, so here the question will be like this. Diagram 1.1 shows 2 cyclists cycling the bicycle. So here we have 2, 1, 2, 1, 2. Okay, and reach the destination, show 3 seconds. So the first diagram 5.1, time taken will be 3 seconds. Then 5.2, there is only 1 cyclist is cycling the bicycle. So another one, the behind one is rest. So the force will be smaller lah, since there is only 1 person cycling the bicycle. Time taken will be longer to reach the same destination. Here will be 7. Okay, so this is what the question given. Okay, so the first point will be, you can see figure 5.1 will be 2 cyclists cycling. Another 5.2 will be 1 cyclist is cycling. So the force will be greater for figure 5.1 compared to 5.2. And the second, you can see with the same distance, time taken for figure or diagram 5.1, only 3. So time taken shorter with same distance, that means the acceleration is greater. So the bicycle will be moved faster in diagram 5.1 compared to 5.2, where taken longer time, which is 7 seconds here with the same distance. Okay, so this is what you need to highlight for the question. Okay, then the question number 1, name the force which added between the bicycle tire and root. Okay, so you can see the motion is at the right side. Definitely the friction will be at the opposite side. So where the surface of tire and the root is contact with, so the friction will be produced. So we are very clear that the answer here will be frictional force. Okay, then the next here is a comparison. Since I mentioned to you, this is a question number 5. Okay, so this will be the question regarding the conception, where we want to compare two figures. And I also already highlight where is the part you need to pay attention just now. Oh? Okay, so here observe that diagram 5.1 and 5.2. So compare the forces applied by the cyclist that cause the bicycle to move forward. So just now I mentioned to you already. So seen in diagram 5.1, 2 cyclists is cycling. So the force will be greater compared to 5.2, which is only 1 cyclist cycling. And the behind one you see is less. Okay, so here you can just mention diagram 5.1 greater than 5.2 is simple. Okay, then number 2, the question asks you to compare the time taken to travel the same distance. Okay, just on the question given already, time taken for diagram 5.1 is 3. 5.2 is 7. So it's very clear. Diagram 5.1 is shorter than 5.2. You can using symbol less than in your answer. Okay, then the third one, based on the answer 5B2 will be this. Compare the acceleration. Just now I explained already. With shorter time, same distance, acceleration will be greater, where the bicycle will be move faster in diagram 5.1 compared to diagram 5.2, where the time taken will be longer with the same distance, so the bicycle will be have the smaller acceleration and move more slower. So here 5.1 will be greater than 5.2. Okay, and then the fourth, the question asks you to relate the force applied and the acceleration. This one through the theory we know already. So the F will be directly proportional to acceleration. So you can see again here, greater F will be have greater A. So you can give your answer, force is directly proportional to acceleration. Or you can give the higher the force applied, the higher the acceleration produced. Okay, so I think this is a quite straightforward question. Okay, and then the next here will be, you can see, name the physics law involved in before. Okay, you can see the diagram 5.1 and 1.2 is actually study the relationship between acceleration and force with the fixed mass, where the bicycle mass and the cyclist mass will be constant here. So we actually applying the Newton's second law of motion. Okay, so this is the answer where the physics law apply in this question. Okay, we left D1 and D2 here. Okay, so what happened to the acceleration of the bicycle in diagram 5.1 when both cyclists bend their body forward? Okay, so here you can see most of the cyclists will be bending their bodies during the cycling racing here. You can see the body, they are bending. Why? Because they actually want to reduce the effect of the air friction so that they can move faster, because the resultant force will be greater. Okay, since the value of friction which is added opposes the motion decreases here. So here very straightforward, the acceleration will be increases. Okay, give one reason for your answer. Okay, just now I explained to you already. We want to reduce the air resistance. So when the air resistance reduce, So the resultant force will be greater because the motion in front same, but the opposite resistance, air resistance will cause the frictional force reduce. So overall, the resultant force will be increases. Okay. Okay, so that's all for my sharing regarding subtopic 2.6. So I return to Cikgu Yani.
Okey, berakhirlah sudah pada hari ini. Okey, terima kasih kepada Cikgu Peh atas perkongsian yang sangat padat dengan info yang menarik pada hari ini. Kita tukar juga. Okey, tahniah diucapkan kepada semua yang setia bersama kelas pada hari ini dari awal hingga ke saat ini. Sekarang kita akan paskan link sijil untuk dimasukkan ke bahagian chat. Sekejap ya. Saya masukkan dulu. Kita ada link sijil Kita buka pula. Okey, saya dah pastekan link sijil di bahagian chat. Okey, link sijil ini akan tamat dalam tempoh setengah jam selepas live ini. Pastikan anda menggunakan email e-didik, jawi dan email-email yang saya bagi tahu tadi pada awal pengenalan tadi untuk mengisi borang sijil ini ya. Okey, kelas seterusnya untuk subjek fizik adalah pada hari dan waktu yang sama pada minggu hadapan. Tolong sampaikan kepada rakan-rakan kamu semua ya. Okey, kita ada penggulungan ke Cikgu Peh?
So far, saya haraplah semua semua faham yang penting. Okay, so boleh continue sambut bersama family Father's Day lah.
Ya, okey. Dan jangan lupa Happy Father's Day Okay, sila layari www.akademiyoutuber.com untuk dapatkan info terkini dan jadual kelas tuition percuma. Jom kongsikan portal AYU ini kepada rakan-rakan dan guru-guru di seluruh Malaysia. Juga diingatkan semua kelas online ini percuma dan boleh ditonton semula melalui link yang telah disediakan di portal AYU. Okey, presenter semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma, selamanya percuma, insya-Allah. Okey, yang baik datangnya daripada Allah dan sebarang kekurangan datangnya daripada kelemahan kami sendiri. Bunga dedap di atas para ada dusun pasang pelita. Andai tersilap tutur bicara, jari disusun, maaf dipinta. Sekian, terima kasih. Jumpa lagi di minggu hadapan. Okey. Nampak besar pula buku.